Hello, I am back. This is a stoichiometry problem. This is extra practice problem number 5 from chapter 6, our stoichiometry unit. So let's jump right in. At this point, I'm going to keep going through the basics, but if you want to work it, want to skip forward, if you know some of the basic things, then please feel free. All right, so we are looking at this problem to make phosphorus fertilizer, in this case CaH4P2O8. Agricultural companies use the following reaction. Ca3P2O8 plus 2 moles of H2SO4 plus 4 moles of H2O. That yields CaH4P2O8, or that fertilizer, plus 2 moles of CaH4SO6. All right, this is a balanced equation right away. So that's a good thing to know. When we do stoichiometry, remember, quite often they will give us grams of a starting substance. In this case, they are saying grams of Ca3P2O8. We're going to convert that into moles of that same compound. All right, so Ca3P2O8. We are then going to use this balanced equation to be able to convert into moles of CaH4P2O8. And then finally, using molecular mass, we are going to be able to get into grams of what it is that they're asking for. So again, in this case, CaH4P2O8. All right, so that's our roadmap. Very first thing I am going to do is I know I am going to need the molecular masses here. So I'm going to go to my periodic table here, and I am going to say that we have, where did my periodic table go? Sorry, technical difficulties. Please stand by. I don't want to have to start again. Oh, sugar and spice. All right. No, I'm not starting again. Yay. All right. Periodic table. We've got Ca, and then we've got three atoms of it. Calcium is 40.08 atomic mass units. Just find that on your periodic table. Then you've got phosphorus. We've got 2 of those. 30.97. Okay, then we've got oxygen. We've got 8 of those. Everybody should have this one memorized by now. All right, when we do that math, we get 120.2, 61.94, and then we get 128.0. All right, when we add these up, we get, what am I doing? Yeah, we get 4, 1, that's 0, 1, 3. All right, we're going to stop here at 310.01. All right, for our significant figures. All right, and remember that number represents 1 mole for every 1 mole of Ca3P2O8. We've got that many grams of that substance. That's what that molecular mass helps us sort out. All right. Now, let's go ahead and look at the next one that we've got to do here, and that is the CaH4P2O8. All right, we're going to do the same process. This time we have hydrogen in there. P and O. So we've got 1 calcium, 4 hydrogen, 2 phosphorus, and 8 oxygen. Again, I like doing it this way. It keeps everything straight in my head, that I'm attributing it appropriately. So calcium is 40.08, Hydrogen is 1.008. Phosphorus is 30.97 and 16.00. So when I multiply those out, I will get 40.08. I'll get 4.032. I get 61.94. Oops, it doesn't line up very nicely. And then I'll get 128.0. All right. So adding these up, I would get 250,432, or 234.052. We're going to cut it off for significant digits right there. So 234.1. We've gone over significant figures, significant digits many, many times now. So you guys, if you still have questions on that, message me, but I'm going to keep moving on now. All right, 1 mole, and the substance we have here is CaH4P2O8. A few of you have asked, why do I always write the name of the substance right next to the moles or the grams? Pure sanity. And it also tells you what substance you have the mass for, or the mole quantity for. All right, hopefully you guys have written those things down. So we're going to use those now to get into to our conversion factors. All right, so what we started with was, they told us we started with 2.5 times 10 to the third grams of Ca3 P2O8. All right, remembering our roadmap that we made for ourselves, we said that we're going to go from grams of Ca3 P2O8 to moles of C3 P2O8, then continue on into the fertilizer that they're asking for. So I'm going to make myself, I think I wrote too big. We'll go from there. All right, so I'm going to start out with grams using that molecular mass that we just calculated. All right, I can say that I know the relationship between the grams and the moles of Ca3P2O8, and that is 310.2, I think, right? No, point 1? 0.1. All right. And then grams of, Ca3. Naughty. All right, Ca3, P2O8. All right, and we'd have 1 mole of Ca3, P2O8. Okay, now we're in, we can get rid of the grams of Ca3, P2O8. Now we're in moles. Okay, remembering our roadmap, we go from moles of what we have to moles of what we want. So we are now going to look back at our equation. And our equation was Ca3P2O8. All right, there's 1 mole of that. And there is 1 mole of CaH4P2O8. So 1 and 1, I can say 1 mole of this will yield 1 mole of this. All right, so that's exactly what I'm going to do. Do you need to write this? Yes, you do need to write this, because in terms of labels, that's the only way it's going to work out. So we've got 1 mole of Ca3P2O8 and 1 mole of what we're looking for, which is the fertilizer CaH4P2O8. Okay, they do share a number of atoms in common, but this is a unique configuration, so that's what we're looking at. All right, next I'm going to check my labels. Moles, good. All right, I've got moles of what I want, moles of that fertilizer, CaH4P2O8. And now I am going to take that molecular mass that we calculated for CaH4P2O8, And I'm going to say, all right, for every 1 mole of C8H4P2O8, we have how many grams? 234.1 grams of CaH4P2O8. All right, when I calculate all of that out, all right, I start at the beginning, start at what they gave me. All right, multiply with that conversion factor for the molecular mass of what I started with. Then relate the number of moles in the balanced equation. And finally, we're using the molecular mass of what we want to get into the mass of that fertilizer. We will get, drum roll please. Where did I write my answer? There it is. All right, what I get is 1886.8708666. Of course, I can't use all of those digits because they're not all significant. Not all digits matter, sadly. So let's see, I've got 2.5 to start with. 2.5 significant digits. I think that's the smallest quantity I'm working with. So we've got to cut it here. That is going to mean that we're going to have 1.9 times 10 to the 1, 2, 3 times 10 to the third. And that label we have here is the label we are going to use here. CaH4P2O8. Voila! All right, we got to the end. We did it together. Good job, guys. That's it.